Thank you for joining us this session on statistics. It's a small question to do with correlation. It's found in the S1 modules of the Cambridge Mathematics course. This question that we're looking at in this session is to do with finding the standard deviation of TT and GT. In this case, not so much the standard deviation, but the covariance of TT and the covariance of GT. So let us have a look, work our way through this question. Initially, we're told the results of after a sample of 10 students who have recorded the number of hours of television T that they watch in a week before their mock exam, and then the teacher calculated their grade, G, in their mock exam. And we're looking at the mathematics that compares the strength of the relationship between watching television, how many hours they watch television, and their mock exam grade. So the two variables are T and G. Now we're after here the covariance of TT and the covariance of GT. This will be used to calculate the correlation coefficient, which is part B. But for part B, let's just go to part B. Have a look. We should know the correlation coefficient, and the correlation coefficient for part B is we're dealing with T and G. So it will be the covariance of GT divided by the square root of the covariance of, and I'll put GG, and the covariance of TT. And that will give us our correlation coefficient, whether it be positive or negative. So we're told S of GG. We already know this number here. We need to find S of TT, S of GT, which is the covariance for TT and GT, before we can calculate our R value. Now the formulas that we have, my rubber's not working, okay, so let's just back arrow. The formulas that we have for the standard deviation, you would recall, is well, if it's xy, this is two variables. It will be the sigma of xy minus the sigma x multiplied by the sigma x over n. So if we want S standard deviation of a covariance of TT, it will be the sum of TT, which is T squared, we're told that here, minus sigma T times sigma T over N. And let's just put that solution here. So sigma TT is 8 squared, 8,702, minus, and then we've got sigma T, which is here, 258 times 258. I'll just put 258 squared because it's multiplied by each other, over n, which n equals 10. So we do that calculation, 8,702 minus 258 squared over 10, and we will get 2,400 sorry, number 2040. Hopefully we get back. We've lost it. Is there anyone online? Now I had trouble with my PowerPoint, so I had to, the screen may have flipped across when I was putting in the number, but the answer for covariance of TT was 2045.6. So we now know we've done this one, and now we want to find the covariance of GT. So let us carry on over here. So the covariance of GT is sigma of GT minus sigma G, sigma T over N. So our sigma GT, we're already told, is 1550.2, and we are subtracting sigma G, which is 63.6, times sigma T, which is 258, over 10. So we do that calculation, and we want three significant figures. Sorry, no we don't. That's for part B. Alright, so we put that calculation in and we get negative 90.68. Alright, so there is our S of GT. So we've done part A. Now that we know these two values, we can substitute this value for S of TT. We can substitute this value for S of GT, and then we already know S of GT. So this will equal S of GT. Covariance of GT is 90.68 divided by the square root of S of GG, 7.864, and then the square root of covariance of TT, 2045.6. Now we get that calculation, we do that calculation as best we can to the right numbers. S of GG, 7.864, S of TT, okay, so we should put that in the calculator, and what do we get? I'm getting a bit slow here. My calculator's not really, keeps giving me error messages. Alright. 90.68. 7.864. You get the negative and three significant figures, 0.715. See how we go with that. Now the teacher also recorded the number of hours of revision these 10 students completed during the week before their mock exam. The correlation coefficient between T and B, between the time that they study, between the time that they watch TV and their number of hours that they recorded, was a negative correlation. So as T increased, B got low. And we have a correlation between G and T, that it is a negative between G and T. So as T is high, G is low. So we can write, so when B is high, T is low. When B is high, T is low. When T is low, G is high. When T is low, G is high because there's a negative correlation coefficient between T and G. Therefore, when V is high, G is high. So give a reason. Therefore, since V is high and corresponds with G is high, therefore we have what's known as a positive correlation. Okay, let's just check these. Let's just check what we've got here. Okay, so in the next slide, I was reasonably hesitant. I wasn't sure here. We had 2045.6. 2045.6 for just put the S of TT, and we've got a negative 90.68, or they've accepted negative 90.7, so negative 90.68, and our correlation coefficient of negative 0.715, and we've got negative, okay, good. And finally, their answering system says high V corresponds to a low T corresponds to a high G. So expect high V corresponds to high G, expect, and it's a positive correlation. So if you revise more for V, then you get a better grade for G, so there's a high correlation. Okay, so that's a brief look at a particular type of question, knowing that just in capital, we mentioned S of GT. If you had to find S of VG, or whatever the variable is, it's the sigma of VG minus the sigma of V, sigma of G over N. And if it's if it's like the covariance of say XX, then it's sigma of X squared minus sigma X over N. So get to know these little formulas and also your correlation coefficient formula. But until we talk again, you practice as many of these types of questions that you can find in other past papers. Let us know how you go, and until we talk again, stay happy.